Yeah, you do. You definitely have done that before. 0.2 is the same thing as 2 over 10, which is the same thing as what? 1/5. So this is 5 to the x is equal to 1 over 5. What power is 1 over 5? 5 to the negative 1. So you have 5 to the x is equal to 5 to the negative 1. So what does that tell you? Done. That's how you do it.
Like, I know, like...
Aubrey, so if you have like 0.8
now I understand.
C, D, E, you just do it over. Okay? Okay, good. Any other question? So the first thing is you're trying to get the same base, correct? What is 8? 2 to the third. 2 to the third. What is 27? 3 to the third, exactly. So you can write that as 3 over 2 to the x is equal to 2 over 3 to the what power? Third. Is that the same base almost?
Yeah.
Flip it. Which one do you want to flip? The left or the right? Flip the right? Sure. You can flip either one. You're going to get the same answer. So you can make this 3 over 2 to the x is equal to 3 over 2 to the negative 1 to the third. What do you do with powers of powers? Yeah, that's 3 over 2 to the x is equal to 3 over 2 to the negative 3. So what does x equal? Negative 3. If you flip a fraction, it makes the exponent negative, or the opposite. It could go negative, positive, positive to negative. Does that make sense?
Yeah.
Our first goal is to get the common base. Once you get a common base, are you pretty much all the way done, pretty much? Yeah, I can set things up later so that you might have to solve a quadratic, but the idea is once you have the same base, a whole lot of complication goes away. Mar?
When you find the x, what does that mean?
It means x is the thing that makes this true when you plug in negative 3.
Wasn't there something else that we had to find the x?
I have no idea what you're referring to. If you give me more information, I might be able to figure it out. No, we just solved it. We just found the one number that makes that equation true. Negative 3 is the one number you can plug into this, the one number you can plug into that to make that statement true. We were testing things before when we were doing inverse functions, so that has nothing to do with what we're doing now. For example, let's say I gave you f of x was equal to, let's say, 2 to the x. What's one point you know that definitely goes to?
1.
That's a number, not a point.
Well, x is 1.
Nope.
Didn't we talk about,
Y is 1.
it's like 0.
When?
X is 0.
Correct. So what's the point?
0, 1.
Correct. So we know it goes through 0, 1. Yep. And what does it look like? Someone use their hands and show me what it looks like.
It's like, it starts up there and goes...
Yeah. So if you go from left to right, it's going to go what? Up. So you know this thing kind of looks like this, right? And do you remember what did we call the x-axis here? What was that called? And there was a word that you need to know. Asymptotes. Yeah. Does it ever cross that green? No. Okay. So one thing I told you about was how to graph the inverse of a function. What is it a reflection over? The inverse is a reflection over something. Correct. So you take y equals x right here and draw it a little bit better than I just drew it. So you know you have y equals x like this, and then you reflect that over. I asked you this on a quiz yesterday, actually. You reflect it over, and you theoretically end up with something like this. So this right here, so we'll call this g of x right here. What's the relationship between f of x and g of x? They are what of each other? Inverses of each other. They are inverses of each other. We just took the inverse, we graphed the inverse. So this is an exponential function. We're going to talk about the type of function g of x is. That type of function is going to be called a logarithm. A logarithm. The first thing you need to know about logarithms is the definition. Not that you understand it, but you have to memorize one line. You have to memorize one really important line. If you don't memorize this, you will not do well on anything we do with logarithms. So there's something super important right here that you need to memorize, and I want you to do this. Stand up right now. Okay. So this is what I want you to memorize right now. Silently, right now, without talking, silently. Memorize what's in the purple right there. Really can put it up high for it. What's in the purple. Memorize that to solve things that look like this. We're going to say, well, 3 to the x is equal to 12. We've talked about that several times because 12, there's no nice number that you can raise 3 to get 12. We're going to use logarithms to do that. We're going to use logarithms to do that. But first, we need to do basic things with logarithms before we can do slightly fancier things. The first thing is you need to know that we have exponents that we can't deal with, so we're going to convert it to logarithms and solve. Sometimes we're going to have logarithms that we can't solve, so we're going to convert it to Exponents. It's another way to write the same thing, and sometimes you can solve it one way but not the other. Can sometimes you solve it both ways? Sure. But the idea is we're going to use each to solve ones in the other that are too hard or just you can't do by hand unless you use it. This kind of makes sense why we're doing this? You need to convert between the two. You need to be able to convert. Remember, and this is what, it's interesting what sticks with you from years and years ago. You go in a circle. To go from logarithm to exponent, go in a circle. You start with the base, you raise it to this power, and what does it equal? 1/5 to the -2 is equal to 20. See that? It's the same thing. You go in that circle. 10 to the 5th is equal to what? 100,000. 4 to the -3 is equal to 1/64. That's how you go from one to the other. That's how you go from one to the other. So then if you go backwards, it's the exact opposite. So for example, let's say I gave you log base 7 of 49 is equal to 2. If I wanted to go to exponential form, can someone raise their hand and tell me what the exponential, what would it be, Connor?
7 to the second.
Equals.
You
You have to know all three. Well, you'd have to have something there. It doesn't matter if it's a number or not. For example, I could have log base a of q is equal to r. Can someone tell me what that in exponential form is? Look, what is it? Exactly. So,
you go from a to the r equals q.
again, we're doing it this way first. We're doing it this way first. So, log base pi of, I don't know, phi. You don't like that. That looks like null set. Of, I don't know, question mark is equal to e. Well, that's not good either. N. Can someone write that in exponential form for me? It's the same process. It doesn't matter what I put in the slots. What is it, Alex?
Pi to the n equals question mark?
Yes, done. Okay, so that's going from logarithm to exponential form. But what else do you need to be able to do? It doesn't matter what's in those slots are treated the same. So let's go from, let's say it was b to the c is equal to d. Can anybody tell me what that log form is going to be? Log base what? Log base b. What is the base right here? You know what the base is. You've done that before. B of what? Of d is equal to? Because, what did I tell you? B to the c is equal to d. So how about we do another one? N to the q is equal to z. Can someone new tell me what that log is? Someone who hasn't spoken yet? Shane, what's the log there? Log base what? Make it automatic. You need to go between them. It depends on what we're trying to solve. So for example, let's say I gave you this. Log base 2 of x is equal to 4. And you're like, I don't know. You haven't told me how to work with logarithms. But you know that is the same as what? Can someone tell me what that's the same as what, Mar?
2 to the 4 equals x.
Oh, look. So what does x equal? 16. You just solved for x. Look, you just went from one to the other and you were able to solve it. The point is, you need the first big thing you need to know with logarithms is how to go from one to the other. If you can go from one to the other, that's huge. There's rules for manipulating logarithms when we get to next section. But right now, you just need to be able to go between the left in. Is it in log form or exponent form? Yeah, what's the giveaway that it's in log form? It says log. Okay, so let's solve for this. Let's go to exponential form. Jen, can you tell me what that is in exponential form?
4 to the -2 is equal to x.
So 1/4 what?
Squared.
Equals x. So x is equal to? Done. Look, that took a whole 4 seconds. Yay, that's it. I usually tell you the truth except when I'm lying. And I told you the truth before when I said this is pretty easy. And that was supposed to kind of be a joke, but no one really got it. They're like, he's not funny. I'm just going to not insult him. Okay. What's the base on this logarithm?
4.
Mar, look at the board, please. What's the base on this logarithm? What's the base? Someone said it. 1/2. The base is 1/2. I don't like it when the book writes fractions like that. You know I don't like fractions like that, right? But the base is that. Can someone tell me, Zoya, can you tell me what the exponential form of that one is?
1/2 to the second
Equals?
equals 3x plus 2. I mean 1.
Sure. What's 1/2 squared equal to?
1/4.
1/4. So is this something you could be pretty comfortable solving? Yeah, you get -3/4 is equal to what? 3x. Divide both sides by 3. So what does x equal? Negative what? Divide both sides by 3. What do you get? Negative what? Wonderful. So, again, what was the hardest part about that log problem? For you guys, at least. Dealing with the fractions, okay? So far, the log problems we have done have been no harder than dealing with fractions so far, okay? I'm just trying to put it in perspective for you, that these are, in fact, really easy. There's this really common rap that people are like, ew, logarithms are really hard. There's only 5 or 6 things you can do with them. How many different ways could you factor a problem? Like, how many things did you have to check when you're factoring something? A jillion. This is so much easier than factoring. So much easier than factoring. So let's do a couple other easier ones. Shane, can you tell me what this is in exponential form? What's the base? So it's x to the equals 3. How do you solve something like that, everybody? Yeah, so what do you think the answer is?
X equals plus or minus.
Ah, look at this. Okay, so just when you guys started actually putting in the plus or minus, we have to go back up and check something here, which is totally cool. But look in the definition here. What does it say about a? For all positive numbers, a. Oh, for all positive. So with logs, this is just something that's really nice about logarithms. No. This is just something that's really nice about logarithms. No negative bases. No taking logs of negative numbers. So just avoid negative numbers in the bases. I'll show you why that's the case later, but it's kind of nice. You should be like, oh, so what's the only answer to this one?
3 plus 3.
Square root of 3. Yeah, exactly. Okay, what about this one over here? This one looks like, oh man, that's super crazy. What's up with that? Can someone put it in exponent form for me? Mar, what is it?
49 raised to the x
Equals?
Cube root of 7.
Perfectly said, yes. So now that's an exponential equation. We can solve that. What's our first goal? What's our first goal when we're dealing with exponential equations? Get the same base. So what number is going to be our overall base? 7. What is 49? So this is 7 squared to the x, and it's 7 to the what power? 1/3. Cube root is 1/3. So it's 7 to the 2x is equal to 7 to the 3rd. If that is true, what has to be true? Correct. So x is equal to? Try again. 1/6. Divide by 2.
Equals to A.
No.
The question mark.
Equals. What's the power of a right there, Aubrey, if it's invisible? What's the invisible power? What's the invisible number right there? Anybody help her? 1, yeah, you got it. All right, 1. So if a to the question mark equals a to the 1, can someone tell me what question mark equals? 1. So what does this tell us? Log base a of a is always equal to what? 1. So what's log base 5 of 5? 1. What's log base 10 of 10? Log base 7 of 7. So if you ever, no, you're going to see this. You're going to see like log of something crazy of crazy. And what are you going to say that equals? 1. You with me so far? If you have the base and the thing are the same, the log is 1. Okay, the next thing here is this. Let me go back here and clip it out. Yeah. Log base a of 1 is equal to, let's say, something. We don't know what it is. That's in log form. Can someone tell me what it is in exponential form? Liv. Excellent. What do you have to raise something to get 1? 0. Exactly. So log base a of 1 is always equal to 0. If you take the log of 1, it's always equal to 0. This is just super helpful stuff to remember, okay? So what are we getting at? We're getting at, let's say I asked you to graph a function.
Base something of 1 equals 0. Is that what you just said?
No, that's not what I said. I said anything, any base of 1. Anything with 1 that the log of 1 is always 0, no matter what the base is.
Try to say.
Got it. Got it. I understand now. Got it. Okay. That function right there. What can you always do? I just said it a minute ago. You can always what?
Plot points.
Plot points. Right. So let's plot points here. Everybody stand up and just watch. The only trick we want to do here is we want to pick x values that make it easy to solve for the number. So let's say we did x is equal to 1. When you plug in 1 into this, what's log base 2 of 1? I just said log of 1 is always what? 0. Log of 1 is always 0, no matter what the base is. When you plug in 1 into a log, if it's just log of 1, it doesn't matter what the base is. What is it always equal to? 0. Right? Are we good so far?
Oh, so it's like how if
Look, I just said it right here. Log, doesn't matter what the base is. So what is log base 2 of 1? 0. What's log base 3 of 1? 0. It doesn't matter what the base is. Okay, but now let's pick some different ones here. What about if I picked 2? What's log base 2 of 2? 1. I just told you that log base a of a is always equal to 1. We need to pick the next one a little carefully, so I'm going to pick 4. So log base 2 of 4 is equal to something, right? So 2 to the question mark is equal to 4. So what's question mark equal? 2. I'm just picking ones that give us nice points, okay?
Oh, right, yeah.
Yeah, no, it's fine. Take a second. It's moving stuff around, and I realize it's either going to be like, oh, I get it, or it's like, wait a minute. And definitely make us wait, okay? What's the next number I should plug in? I'll give you a hint. Not 5, not 6. Plug in 8, because you need powers of 2 to make this nice. Because look, you have log, sorry, I don't know why it does that. You have log base 2 of 8 equals question mark, so 2 to the question mark is equal to 8. So what does question mark equal? 3. I'm just picking nicer points, right? So do we have a lot of points here? Yeah, so what you can do is what does this look like? You know when x is 1, it was 0, right? At 2, it was, what, 1? So this was, what, 1, 0? At 2, it was 1. And then at 4, what was it?
2.
So what does this curve actually look like? Looks like this, right? Does that match the shape we talked about before? And what does it do to the left? You can plug in numbers that are fractions, right? It dives. It goes down real quick. It goes, and you can see that. How do you see that? Let's plug in, let's say, -1/2 into this thing. So what do we have here? Log base 2 of -1/2 is equal to question mark. So 2 to the question mark is equal to -1/2. That's -2 to the -1, right?
Wait, why is there 2 there?
Oh, not -1/2. It's a half. Sorry, half. So what does question mark equal?
Wait, didn't you plug in a negative half?
No, I wanted to plug in positive. That was a mistake. If I plug in a half, what do you get? You get 2 to the question mark is equal to 2 to the -1. So what does question mark equal? -1. So what do you get here for a point? You get 1/2 comma. Does that match the shape we want?
I'm confused why there's 2 at the log base.
Because that's the function I made up right there. I just made that function up instead. I just said we're going to graph that function right there. So do we have a graph? Does that match the shape we want it to match? Yeah. So again, if you get lost, make a table. We chose careful numbers though, right? We chose careful numbers. If you choose like 5, you get stuck. Like 2 to the 1 equals 5. We don't know that yet. We're learning logarithms. I would pick 16 next. But you don't need to plot more points. You have an idea. If you had to, you would pick 16. Exactly. The next power of 2. Okay, sit down. So 1/2 to the something is equal to 2. If you flip 1/2 over, what happens to the question mark? Yeah, 2 over 1. And then what happens to the question mark, though? Negative question mark, right? Exactly. Not sure why it's doing that. That's nice. Thank you. So what do we... Oh, that's a really terrible question mark, isn't it? Hey, do we have the same base now? What's the power of 2 right there? 1. So you have 2 to the negative question mark equals 2 to the what? So negative question mark is 1. So what does question mark equal? -1. So we have 2, -1 here. If you plot these points, we had 1, 0, right? Let me do this roughly. Sorry. If you plot these points, it's going to look a little different. You're going to get something that looks like this. We knew it was 1, 0 right there. But what was 1/2? 1. And what was 2? -1. So what does this curve look like? It goes down. What's the difference? What's the new thing in this one? What number up there do you not really like too much? The 1/2, right? This is because this number right here, the base, is between what and what? 1 and 0. Do you remember how the exponential graphs changed when you were between 1 and 0? Yesterday? They went from going up to going down. It's the same thing here. When the base is between 0 and 1, you get this type of shape. When the base is, what's the base? We like the base here. This was 2. That number is what? Greater than what? 1. When it's greater than 1, functions go up. When it's less than 1, the functions go down. Your homework is on 10.3 tonight.